Somebody call Fluffy Mexicanic. I've got myself a super fancy Nissan Infiniti right here with a parts cannon AC diag. Customer states they replaced every part on the AC system and it still does not work. Today, we're gonna find out why. Hello there everybody, good day to you guys. Welcome back, and it's a busy, fun Monday around here. I can tell you what, today we're gonna be working on this parts cannon from another shop vehicle. I believe this is an Infiniti QX56. It's equipped with the 5.6 liter V8, one of the Ochos. Now, I said parts cannon because this thing was in and out of a couple shops and they're trying to make the AC work, and the customer states that the AC continues to blow warm after replacing all the components. AC not, hang on, there's a note here. AC not working, only works when engine temp is low. That's interesting. So if it's a cold engine, I guess the AC will work, but when the engine heats up, it stops working. Well, that's very interesting. Now looking down, you can see the compressor down there, just past that hose. That looks like it's a new compressor, so that goes along with my parts cannon. We've got some new valve cover gasket, or new valve covers. The originals, I believe, are plastic, and these look to be aluminum. I don't know if they changed valve covers to make the AC work, but that's not the situation. Let's see. We have a new heater control valve right here. It's an electronic actuator, and it runs a valve inside to stop coolant flow into the heater core. So I guess they shut off heater core flow for AC performance. That thing's been replaced. Let's see what else has been replaced here on this. Looks like it's got a new condenser up front. Is that right there? Not super new, but it's not the original from what I can see so far. It's got a new low pressure switch right there, so they changed that. Auxiliary fan is present. Any other new parts around here? Out back at the expansion valve at the firewall, that's new. I can see it from here. Yeah, right? It's a little deep in there. Let me see if I can get you guys down in that hole a little bit. Take a gander. I don't know if I can get you in there enough to see it. I don't think I can. Yeah, see that little skinny line right there? The expansion valve is against the firewall just behind that guy, but there's so much in the way. I can see it kind of from here, and it is very shiny. So yeah, I concur. The parts cannon has been fired on this particular Infiniti. Let's go inside and start the engine. We're gonna check AC compressor operation here. Beginning engine starting sequence now. Heard an exhaust leak at the manifold. We've got 195,752 miles on the odometer. We've got a thermal meter ready to rock and roll right here. Let's see what our temp is so far. It's hot in here. Over 100 degrees so far. Okay. AC is in fact turned on. We're down to cold mode, 60 on both sides. Let's do some function check real quick, make sure all the doors work. Let's recirc. I can hear the door operating inside. Yeah, they've got the whole cover business removed on this side for some reason. I guess they gave up. Let's crank up the heat and see if hot air comes out at least. I heard the door move. Now it's 110 at the thermal meter. Crank this back down. Yeah, getting a little warm in here. Okay, let's hop out, go back under the hood here and check the compressor. Yeah, these parts cannon jobs require diag, like a visual diag, just to go through what the other place did or the other person did and verify that their repairs are accurate and correct, and also to verify. So looking down, see the compressor is not running at all. I can see the end of the clutch down there. She's not doing anything. I suspect we've got some kind of control problem, or maybe like a power and ground problem to that compressor. First thing I want to do is make sure that this system is able to operate and that it's getting the correct permissions from the controller. So let's get the scan tool. It's not over here. We're gonna get the scan tool out, hook up to the HVAC control module, and we're gonna pull up data. The data stream should list compressor clutch permission granted or denied. So let's fire up the Snap-on Apollo here and see if we have any trouble codes or data lines that are going to indicate possible problem. Powering on. Beep. Let's get this guy hooked up. Illumination. The cord's twisted. Woo, there we go. All right, let's find our little plug here. It's over there in the knee bolster. Give it a flip, plug it in. So we're gonna pull the vehicle up, access the HVAC control module, see what the data tells us. All right, scan tool is going through, it's powering up, and it is starting to request information from the control module. Okay, we're in. We're gonna scroll down to HVAC, right there, HVAC control module. Thinking about it, waking up, IDing ECU. Let's see if there's any trouble codes. First, no codes present. Good. Let's go ahead and go to data. We wanna see compressor on or off. Now the AC button is turned on. That should be commanding the AC compressor to the on position. So let's scroll down here and look for the correct PID and see if permission has been granted by the control module. Doesn't look like it. That's a short list. Mode feedback, mix, voltage, nope. Okay, we do not have what we're looking for here. That was not okay. Backing out. I found it. I went into body control module, air conditioner switch on, right? So we're gonna go ahead and push it off. It's reading off right there. Push it on one more time. On. So we've now verified that the control module is telling the compressor to actuate, yet the compressor is not actuating. So now, let's bust out the wiring diagram and see what is in line on that circuit, and we'll check the component at that point. So, unlocking the auto to the all data with us. Shut that down. Pew! Powering down. Oakley dokley. So we have the AC system electrical diagram pulled up. And over here on page 3, let's go ahead and zoom it in. Zooming. AC compressor, left front of engine. That's a yellow and black wire. Looks like a single circuit. That's the ground symbol right there, that little dot and those 3 lines. So the compressor ground for the clutch is grounded at the case. So we only have a 1-wire circuit powering the compressor clutch. It's a simple circuit, 12 volt. So we follow that yellow wire back. That runs over here to, what's this big module? The intelligent power distribution module at the right rear of the engine compartment. That's a fancy word for fuse block. So that runs to the fuse box right here. And we're running up to an AC compressor relay, which looks like it's integrated into the fuse box. That relay is powered by fuse 42, which is a 10 amp fuse. So let's head over to the integrated power module in our Infiniti Nissan and find fuse 42. Okay, so integrated power modules here. Let's see what we've got. Looks like there's 2 little fuse block guys in here. Trailer, running lights. I don't think that's the one. I did not see fuse 42 in there. Let's check the next one. Ah, here we go. Now we're cooking with some Crisco. What do we have here? 10 amp down there, AC compressor. Any more AC compressors or just the one? I think it's just the one. Front of vehicle, radio. Which one is it? AC all the way to the left. Oh, look, hang on, wait. There's another key. There's a key also on the actual fuse block. Hang on, let's see if it's on there. Because this key does not line up with the configuration of those fuses and relays. That doesn't make any sense. So we're gonna go off the key that's written down on the thing there. Let's see if we can't see. AC clutch, I see it at the bottom. AC clutch, yeah, it's down here. AC clutch F8, it says F8. So we're looking for F8, the Ocho. F8, it's gonna be that one right there. I don't think you guys can make all that out, but let's pull that fuse and check it real quick. We'll go in with some handy dandy extra long needle noses here. Foxtrot Ocho. There she is. That's a 10 amp like the diagram said. And this 10 amp fuse, that looks good. Okay. We all know looks can be deceiving, so let's just check it. We're gonna put the meter on continuity here. What that means, it's gonna beep at us whenever these touch. That's gonna let us know that there is a connection that's been made. So we'll just check it with the meter. And it's 0.3 ohms resistance, that's a good fuse. Okay, so we're gonna put it back. We're gonna start the AC and then check it for power. Just plug that guy right back in where it lives. Please go in. There we go, she's plugged in. So now, gravity. Set the meter up. We'll go start the vehicle and check it for power at that fuse. Let's check our meter real quick. The negative's on the battery terminal negative. We have battery voltage here. Actually, let's check it key off first, see what happens. Gravity. Stay right there. Ooh, I'm getting sweat in my eyeball. Okay, there's voltage on that fuse. And voltage on both sides. See that? Okay, so that means the relay is powered. Here, let's just go ahead and drop the flashlight down there. Let's go ahead and fire this thing up and check that fuse while it's running. I realize that's kind of not that necessary, but I'd like to just double check power while the engine's running. I realize that's a duplication of efforts, but we are going to do it anyway just to be thorough. Beginning engine starting sequence now. Alright, we're rocking and a rolling here. So, going back into F8. With engine running, F8 says 1389 volts, which is charging voltage, and 1389. Yep. And to be extra thorough, I just turned off the AC compressor, the switch, and we still have voltage. So why do we have voltage at the compressor? Why do we have voltage at the fuse when the compressor is turned off? And that is because that fuse is hot at all times. So there's a bus bar in there on one side of the fuse. That bus bar is supplying power. That is the load power for the compressor clutch. Now when we turn on the HVAC module, the button in the dash, that's going to actuate this circuit right here. This circuit is going to close the windings for the switch in the relay and then allow power from the fuse to pass through the relay, because the relay carries the load, not the activation circuit. So you have activation circuit on one side, then the load carrying circuit on the other side. So we have power supply to the load carrying circuit, but what we do not know is if that power is making its way past the relay and going to the compressor. So now let's go to the compressor on the vehicle, unplug the compressor, and then check for power at the compressor wire. What that's going to tell us is if the compressor clutch is any good or not. If the compressor clutch has failed, and I don't know why it should be failed because that looks like a new compressor down there, but new doesn't mean good, it just means it's not used. So what I need to do is get a hold of that connector right down there, a little black connector just below the green one, and we're gonna probe that connector for power. If I can do this here. Oh, a little warm in there, but I got my finger. Yeah, buddy, I got it. I have the connector in my hand. Ow. still have a shoulder injury, and I articulated my arm in a fashion that caused me pain. So any Hoosiers, just quit complaining about my worn out joints and whatnot. I've got an appointment to go get it looked at later. I think tomorrow, actually. Okay, that's not what I wanted to do. I want my flashlight back. Stop it. So here's what we're gonna do. Here's our connector right there, that unit going to, or coming from, I'm sorry, the relay in the fuse box. We're gonna start this engine, and I'm gonna take the multimeter right here, and we're gonna check for power at that connector with the AC on and the engine running. So let's fire it back up. Beginning engine starting sequence now. Okay, meter's back out. We're still on voltage. I've taken a jumper wire, I've taken a jumper wire and connected the ground side to the meter, to the negative on the battery, just to give me some more extension. Now we're gonna go in and probe that connector down below. Got a little probe connected to another jumper wire, connected to the meter, right? Because I can't get this into the hole for this without breaking the socket for this. So we're doing this without breaking it. We're not just shoving stuff in there and hoping for the best. That's not the way to do it. Anyway, meter's right here. Let me get it plugged in. Woo! I touched the fan. Bad. Yeah, it should go without saying you should not touch moving radiator fans. I caught it with the edge of my wrist right here. No injury. It just let me know it was there. All right, enough screwing around. So looking down at that red lead wire, I have that plugged into the power source for the clutch. Here's the end of the red lead, plugging that into the meter. If the system is allowing the compressor to actuate, we should have 13 and some change volts right here, right now, and we do not. We got 0.6 volts. So what's happening here is the electrical circuit that powers that compressor clutch is not sending power to the clutch. Okay, so clearly we don't have power coming to the compressor. So somewhere in the circuit, which we're gonna re-review one more time, something in that circuit is causing an open. Now, if you take a look right here, I've got a little blue wire there. Now this little blue wire, I have that connected directly to the compressor connector. You can maybe barely see the blue down there on that little black wire to the left of the red wire, and I don't have my my Olight laser pointers to show you today. It's in my house, but I've connected this lead to the compressor, and what we are going to do is we're going to power this lead right here to the battery. Okay, so let's connect it. That's not going to work that way. Get on there. Okay, so now we're grounding the compressor clutch to battery ground. That's not necessary because it is grounded. Let's go ahead and power it and see if our compressor comes on. Ready? Oh, saw some sparking. Yeah, there it is. That compressor is now running. What we have effectively done is bypassed all the control circuits in the vehicle and it made that compressor turn on. So let's go into the cabin real quick, check it for cold air, make sure the system is capable of functioning. And according to our thermometer, we're down to 80 degrees off of 110, and I expect that to continue to fall. So let's go back and review. Yeah, that's turned off. Turn it back on. Oh no, the AC was off. We got to go check the wire one more time. I thought that was on. Hang on, bear with me, folks. Bear with me. I made an error in my testing protocol here. Real quick. We're gonna ground that one more time. Get rid of you. We're gonna ground our meter one more time. Down there. Then we're going to recheck for voltage one more time at the connector. And 0.7 volts, okay. So even though I had the switch turned off, the result is still the same. Forgive my error just now. So let's plug in that compressor once more. Power it back on. I heard it run, you heard it click on. I see the compressor running, good. So we're gonna put the windows up in the vehicle, let the AC system run. I can see you. We'll let the AC run and do its thing, and we're gonna see what kind of temperatures we get out of this thing after we come back from reviewing the digital grams one more time. That's the wire diagram. So we're going 80 degrees, fan on high mode, recirculation on. Recirculation, what that means is it's going to take all the air in the cabin and then recool it and send it back. If you have recirculation off, it will pull your cabin air from outside of the cabin, bring it in, cool it, and then send it out. So after you've been running for a while, theoretically on recirc mode, you can get a colder temp inside of the cabin as opposed to drawing the hot air from the outside. And in some situations, it's so hot outside that the hot air just is too hot for efficient cooling, and you want to turn on recirculation. The downside is there's no fresh air coming in, you're just using the same air inside. So if you're on a 10-hour road trip, you never open your windows, recirc is just going to keep that same air inside, whereas you turn it on the outside, you'll be bringing in some fresh. Let's fire this bad boy back up. Turn on computerizer. Okay, back at our diagram of our fuse block assembly here. I highlighted things for no reason. Now I don't know how to unhighlight them. Okay. Well, anyway, we've got our intelligent distribution power module, right rear of engine compartment. That's the component with all the fuses in it. That's also the component that houses the AC relay. And this is not fused. Power runs through. So what I think we have here, the ignition system works, so I know that this has power. If this did not have power, then none of this supporting equipment here past this ignition relay would have power, but I know we have data communication lines because the scan tool is talking to things. We have a fan motor. That's right there. The fan motor runs. So, and the cooling fans are also running. Okay. And just to check to make sure the electronic fan is running, we can see right here it is chooching away, no problem. What's the diagnosis, Dr. Ray? The diagnosis, in my opinion, and based on all of the previously gathered information, is that the AC relay itself has failed. And it has failed inside of that integrated power module. And since it's an internal component, that means that the relay is not replaceable. And that means we will have to replace the integrated power module or the fuse box. Now, this may or may not require some programming. I may or may not be able to do that here. If it needs to be programmed and I can't have it programmed here in-house, I'll have to send it to, well, I'm not sending it to the same Nissan, Jeep, Chrysler dealership that stole my instrument cluster money. I'll have to find a new dealership to send it to. But yeah, I'll have to send it to the dealership for programming if I'm not able to program it myself. But I need to locate parts, price it, sell the customer, figure out if I can program it or not, and then go from there. But this is definitely a diag. We need to replace the integrated power module or the underhood fuse block, whichever verbiage you prefer. But that is the solution to the problem. I'm billing 1.5 hours for this job right here, which is a whole lot cheaper than throwing parts at it. Like I said, we put a compressor in it, we put a new charge in it, we put a HVAC module in it. Looks like we changed the sensors, the condenser, and the TXV. All to no avail. See, that's the danger of the parts cannon. And looking over here, we're down to looks like 63 degrees on the Fahrenheit scale. The zoom doesn't work that well on this. If I try this. I'm learning a new camera while we're doing this. There we go, look at that, static zooms. Yeah, not that great. It only goes up to 2x. Yeah, I can't really tell. But yeah, I'm looking at it, we're about 62 degrees right now. Sitting stationary, not moving. And on a 90-something 5-degree day, I think that's all right. Let's go check the temp real quick inside of the building. Oh yeah, we're 94 degrees inside right now with the fans going and the AC on. It's a little warm today. Did you say hot, Mr. Troy?
I'm sweating.
You a little warm up here? Hey, the fellas really liked your follow-up diag on the EcoBoost 2.7 Ford from the other day. It was a really good job. They liked your verbiages.
My verbiages?
What are you doing? Changing spark plugs in a Ferd?
Yeah.
Yummy! Nice and organized. Yeah, look at these. Proprietary Ford spark plugs. I bet these cost about 38 bucks a piece. Crazy sauce. All right, let's do one more recheck real quick and see where we're at. We're hanging out just under 60 degrees while stationary. 94 degrees outside. That means we got a 34 degree temperature drop based on static conditions, and considering the high heat and high humidity today, the system is functioning flawlessly by my estimation at this time. We just need to go ahead and make it turn on when you push the button. So I'm gonna call up Nissan Infiniti. We're gonna get a hold of a part number for this thing, price it out, labor it out, get it sold, and then kind of go from there. Thank you guys for watching this diag video on this Nissan Infiniti AC system. Let me know what you think about this system, this failure, and that integrated relay design in the comment section down below. Do not forget to engage that like and subscribe button, and most importantly, have yourselves a fantastic day. See you guys later in a video, in a transmission. By the way, if you'd like to experience the joy of owning Olight flashlight products, check out Rain Man Auto in the link down below to visit our merch store. See you guys later in a shameless self-promotion. Finalize powering down. Goodbye, Nissan. Till tomorrow.